Bismillahirrahmanirrahim. In the name of Allah, the most gracious, the most merciful. This is third online class of Class 10th Federal Board. Subject is chemistry. Students, you are studying chapter number 9, chemical equilibrium. You have studied two topics from this chapter, and uh, today is lecture number 3, and the topic is law of mass action, and also the derivation of the expression for the equilibrium constant. You have in previous classes you have studied reversible reactions, and the dynamic equilibrium. This law related to these types of reactions, and you know that chemists generally express the composition of equilibrium mixture in terms of numerical values. These values relate the amounts of products to reactants at equilibrium. These values can be determined by using a relationship known as the law of mass action. This law was put forward by two scientists, C.M. Goldberg and P. Wage, in 1864 to describe the equilibrium state. This law states that the rate at which a substance reacts is directly proportional to its active mass, and the rate at which reaction proceeds is directly proportional to the product of the active masses of the reactants. Here, term active mass is used. The term active mass represents the concentration of reactants and products in mole per dm cube for a dilute solutions. It means that this is the active mass which participate in a chemical reaction, and this mass is expressed in terms of square bracket. Okay, come to the derivation. Consider a hypothetical reaction in which A moles of reactant A and B moles of reactant B react to give C moles of product C and D moles of product D at equilibrium. Here, chemical equation is written: A react with B and produce product C plus D, and product again decomposes and backward reaction starts, and this product produces reactants again A and B. This reaction consists of two reactions, forward and reverse reaction. Let us first discuss the forward reaction. A and B are the reactants, whereas small a and small b are their number of moles. So according to the law of mass action, the rate of forward reaction is equal to the rate of forward reaction is proportional to the A and B, that is reactants. Whereas the rate of reverse reaction RF is directly proportional to the product of C and D, where small c and small d are the number of moles are given in the balanced chemical equation. By removing these proportionality constant, we introduce a constant here. Rate of forward reaction is equal to Kf, reactants A and B, and here rate of reverse reaction is equal to Kr. Kr is the proportionality constant for reverse reaction and is equal to product C and D, where Kf and Kr are the rate constants for forward and the reverse reactions respectively. At equilibrium state, Rate of forward reaction is equal to rate of reverse reaction. When both reactions begin, then a time will come when both the reactions, forward and reverse reactions, become equal. It means that RF is equal to RR. Rate of forward reaction is equal to rate of reverse reaction. Thus, by putting the values of RF and RR, we get KF is equal to reactants A and B, whereas Kr, rate of reverse reaction, is equal to product C and D. On rearranging, or by taking the constant on one side and the variables on other side of the reaction, the above equation becomes Kf divided by Kr is equal to product C D with their number of moles present present in exponent form divided by reactants A and B with their number of moles. Here Kf and Kr is equal to Kc, which is equal to product over reactants, that is CD over A and B. The small letters which are written in power as a power are coefficients in a balanced chemical equation, whereas capital letters which are written in square bracket is the concentration of product and reactants. This equation is called equilibrium constant expression. Here Kc is equal to Kf over Kr and is known as equilibrium constant, and the above equation is called as equilibrium constant expression. The square brackets indicate the concentration of chemical species at equilibrium in moles per dm cube. Thus, the equilibrium constant expression for any reversible reaction can be written from its balanced chemical equation. Concentration of products is taken in the numerator and concentration of reactants in the denominator. In Kc, the subscript C denotes molar concentration at equilibrium. This expression is for chemical equilibrium constant. All the reversible reactions can be expressed in this form. Okay, this is all about law of mass action and the derivation for the equilibrium constant. This is your home task. You have to write the answer of the following questions. Define law of mass action. What does active mass means? How is active mass represented? Drive an expression for equilibrium constant. Thank you so much.